Okay, today we're going to be looking at position vectors. So previously we were looking at displacement vectors, and these were simply free vectors in space. They weren't dependent on an actual position. You weren't looking at the vector in respect to any particular position, whereas a position vector means it's located in space with respect to an origin. So let's have a look at, here's our origin, and then we've got vector A, and we've got here vector P, and here we've got vector B. And this is in two-dimensional space, and each one, OP, and is the position vector with respect to the origin. Now, if let's just draw, let's get some different colours and just extrapolate this. That's the wrong colour because it didn't show up. So imagine we extrapolate this out to make a parallelogram. So we've got our parallelogram, and the vector that A is on is parallel to this line here, and our vector that B is on is parallel to this line here. And so what this means is we can write the vector, we get our black back, OP as the sum of some scalar m multiplied by A plus some other scalar n multiplied by vector B, where m and n are scalars. Because if we say if we doubled the length of this or tripled it, we come to here. Then if we add on to that A, then A again, we come to point P. And that's all to do with the fact that we've got these A and B are parallel here and here. This then leads us to the concept of Cartesian components. And I think we will just get a new page up for this. So let's let vectors A and B are perpendicular and they're unit vectors. So let's draw that. Now I'm going to draw these in red. So we have a little vector here and a little vector here. Now, what we've got here is an x and y axis. Now we call the vector in the x-axis I, and we call the vector in the y-axis J. And now we will extrapolate that out to give us a proper set of x and y. Not too far up there. Coordinates. Now let's say we have some value of P with coordinates x and y. And we can give this a position vector. Here's our position vector. And OP, let's put the O for the origin, OP is going to be X times I plus Y times J. Because this, remember this, these are our perpendicular unit vectors. And we can use this to therefore find the position vectors of points in the Cartesian plane. So say we had point 4, 5, and so the position vector that we could have 4, 5 can be written as 4i plus 5j. Now we can add a third dimension onto our unit vectors here. So we've got our j, we've got our I, oops, and we can also have, oh wait a minute, I'll do those other way around, let me, so it makes it a wee bit bigger. This is going to be on the flat here, that's going to be our y coordinate. This is our x coordinate, so this is our I, this is our j, and imagine it's coming out of the paper. This is our z coordinate, this is vector k. And again we can extrapolate these out to give us our axes. This is like z, y, x, and say we had some point Q with coordinates x, y, z, then O, Q would be xi plus yj plus zk. And so if say Q had actual coordinates 4, 2, 3, the position vector would be written as 4, 2, 3, or 4i plus 2j plus 3k. Now let's do some examples to see this in practice. The position vectors of A, B, and C are given by vectors A, B, and C, where A is 2, 5, minus 3, B is 0, 4, 6, and C is minus 4 to 24. So write A, B, that's terrible writing, and C in terms of I, J, K. And then give AB and AC and describe the relationship between the points. Justifying your answer. Okay, so firstly we want to write A, B, and C in terms of I, J, and K. So vector A is going to be 2i plus 5j minus 3k. Vector b is going to be, well, it's got no I, so it's just 4j plus 6k, and vector c is minus 4i plus 2k plus 24. Oh, it's wrong way round. Sorry. Pay attention. 2j and 24k. Okay. Now, you can draw a wee sketch to help when you're doing A and B. But we want the vector from A to B. Now remember, these are like O to A, O to B. So let's say we had vector A. Here's the origin. Here's A, and B is over here somewhere. This is vector A here, O to A, and this is O to B. So A to B is going to be A back to the origin, then plus the origin up to B, which is the same as our OB minus OA. So this is going to be reversed. So let's write this in. So we've got our OB, which is our vector B, which is 4j plus 6k. Then we're going to minus, because this one has to go backwards, so it's minus this, 2i plus 5j minus 3k, which gives us minus 2i, and then we've got 4 minus 5, which is going to be minus j, and then 6 minus, so it's plus. 6 plus 3 is 9k. Now A to C, again we're doing, if you do the same idea, where you've got, say your origin here, you've got C over here, this is A, this is C, you're going from A, these are the origin vectors, A to O, plus O to C, which is O to C minus, this is going to become minus OA. So our origin vector for point C is this, our position vector for point C, minus 4i plus 2j plus 24k. And then we're going to minus this again, so 2i plus 5j minus 3k. Working all that out, we get minus 6i minus 3j plus 27k. Now if we look at the two results we were interested in, let me just get is this one here, because we've got so many vectors written here. There we go, in this one. Now, describe the relationship between the points. So if you look here, we've got 2i, minus 2i, minus 6i, minus I, minus 3i, 9k plus 27k. You can see that AC is equal to 3AB. Therefore, vectors are parallel. Since they have the same point A in common, AB must be collinear. They must lie on the same line. So A is shared, so AB and AC must be collinear. They must be on the same line. So if you've got, here's A, say B's over here, here's C over here. They must be on this same line. Okay, let's do another example. So we've got this diagram. Now I'm going to draw, I'll draw it in black first. Bear with me. And now we've got so we have our origin, point A, B, C, D, E, F and G. And we've got a point M here, and we've got a point P up here. And I'm just going to draw in our axes. Let's get a better colour. So this is I, J, and K. Okay. Now, we're told the sides are length 4 centimetres. I, J and K are our unit vectors, and they're parallel to OC, OA and OD respectively. Point M lies on FB such that FM equals 1 centimetre. N, we'll write N here. So we've got N is midpoint to OC, and P is at the centre of DEFG. So this stops square at the top. P is meant to be sitting right in the middle of that. Okay. So we want to express NP and MP in terms of I, J and K. Now, let's think about this. NP. So we're starting here. We're not starting from this origin. We're starting from this point here. And the position of P with respect to N. So it'd be like a vector coming up here and joining these 2 points. Now, we know that the cube is 4 centimetres squared. It's 4 all the lines are 4 centimetres. NP is parallel to this Y direction. So if we look here, if if we come out this y direction, and this, so if we think of a point on the bottom square, and we're going to call this P, not P, like a mirror image. From N to P, we think of a parallel line that comes out here, which must be 2 along. So NP, oops, that's not a P, it's a B. NP must equal, so 2 along J, and then from this point here, you have to go straight up and you'd hit P. So, and because it's 4 centimetres high, that's 4K. Similar logic to point M. So this time, so we're looking now for MP. This time we're going along the back wall of our cube. So we're going to go along the back wall here. I might actually use a different colour. Let's use green. So we're going to go along the back wall until we're parallel to the point that would, if P kind of was maybe not sure, would belong there. So this would then be, but we're going backwards towards the origin, so it must be minus 2, because it's halfway along, minus 2I. Now we're going to come out into the middle of our cube. And again, we're coming 2 out, but it's backwards towards the origin again. So again, it could be minus 2J. And now we're going to go up to meet our point P. And remember, we've been told that the distance from M to the top of the cube is 1 centimetre. So we're going up, and this time we're in the positive direction, so it's up 1 in the K direction, so K. Just plus K. You can do it another way. You can do it by adding the position vectors together. So if you think about NP is going to be OP plus NP is OP plus OP minus ON, which then brings us back to N. And similarly with the MP one, it would be OP minus OM, and you're just kind of tracking a route between the different position vectors that you've got. But yeah, there's the two ways to do this, and I hope that makes sense.